This is a basic lesson in how to work with a formula. There's a little bit of math involved in this. And they say if you write a technical book or produce a technical how-to project, the more math problems you include in it, the fewer people you're going to have follow along with it. Some people don't like math. I really like math. I use some basic practical math quite often in fireworking. And working with a formula is one of the places that I personally do use some math. This is a printout of the black powder formula from the database in fireworking.com. The nice thing about this lesson is that you personally in Fireworking 101 will not have to use any math. So I'm basically going to include this lesson just for informational purposes only. When we get to making black match, when we get to making black powder, when we get to making stars or fountain composition or rocket composition, each of those formulas will be loaded into the fireworking.com database. If you go to that formula and input the amount of composition you want to make, such as 500 grams of this black powder composition, which is a batch that I use for making black match, the calculator in the formula database automatically calculates the amount of each chemical you need to weigh out. If I want 500 grams of black powder, the calculator tells me automatically that I want 375 grams of potassium nitrate, 75 grams of charcoal, and 50 grams of sulfur. So each time we get to a formula in one of the lessons, we'll reference a formula in the database that you can go to and calculate the amount of composition you want to make, print it out, take it to the shop, and you can avoid all the math that I'm going to talk about in this lesson. But this is, I think this is a very useful skill to have, especially if I'm working in a shop on the fly, if I'm working out in the field, say at the PGI convention, and somebody says, Ned, I want to make 48 ounces of black powder. How much of each of the three chemicals do I need to weigh out? It's a good skill to be able to do that on the fly, perhaps simply with the aid of a calculator that I usually take with me wherever I go. So let's work with a simple formula, and I'll show you some of the ways to work with it. Black powder is a very simple formula. It's normally referred to as 75, 15, 10. You'll even see guys and gals wearing t-shirts at some of the events. The t-shirt has 75, 15, 10 on the front of it, and below it says, if you have to ask, you wouldn't understand. 75, 15, 10 is the most classic formula in fireworking, the formula for black powder. All of those parts, 75 plus 15 plus 10, add up to 100 in that formula. In percentages, that is 75% potassium nitrate, 15% charcoal, and 10% sulfur. Since the factors 75, 15, 10 add up to 100, those are then the percentages of each chemical that are used in the formula. Percent means per 100. Cent is the leading word in century, 100 years. A cent is 1/100th of a dollar bill. Cent comes from the old Latin, I'm sure, meaning something to do with 100. Percent means per 100. 75% means 75 parts out of 100. 15% means 15 parts out of 100. 10% means 10 parts out of 100. So that's what percent means. You'll notice that all of the formulas in fireworking.com are expressed in terms of factors that add up to 1. In this case, it's 0.75, which is 75 100ths, 0.15, which is 15 100ths, and 0.10, or 0.1, which is a tenth, or 10 100ths. All of the formulas are expressed in factors that add up to 1. So the decimal factors for black powder are 75 100ths, which means 75 parts out of 100, 75 of 100, which is the same as 75%. But these factors are convenient in that 75 100ths, 15 100ths, and 10 100ths can be multiplied times any batch size I want to make. Let's say I want to make 16 ounces of black powder. Those factors that add up to 1 can be multiplied by my batch size, 16 ounces, to determine how much of each chemical to weigh. 75 100ths times, if I want to make a 16-ounce batch of black powder, 75 100ths times 16 is 12 ounces. 15 100ths times 16 is 2.4 ounces. 10 100ths times 16 is 1.6 ounces. I've determined then my the three amounts of each chemical, potassium nitrate, charcoal, and sulfur, that I want to weigh in order to make a 16-ounce batch of black powder. To double check my work, I add those three amounts, 12 plus 2 plus 2.4 plus 1.6, and verify that they add up indeed to 16 ounces. That's double checking my work. So the decimal factors that add up to 1 in any formula are what I find to be the most useful when working with a formula. I can multiply those decimal factors that add up to 1 times any batch size, 16 ounces, 48 ounces, 100 pounds. I can multiply the decimal factors that add up to 1 times the batch size to determine the amount of each quantity, the amount of each chemical to weigh. Now, quite often we will see formulas that are expressed in terms of factors that do not add up to 1 or do not add up to 100. Sometimes we'll see the black powder formula expressed as 1532. Now 1532 adds up to 20 parts. That means that 15 out of 20 parts is potassium nitrate, 3 out of 20 parts is charcoal, 2 out of 20 parts is sulfur. There is some historical reason why quite often we will see a formula expressed in a way that doesn't add up to 1 or doesn't add up to 100. A lot of the old-time fireworkers made batches that were just the right size to make up in the cut star loaf box that they used. They maybe would make up 32 pounds of glitter composition or 20 pounds of charcoal star composition. And so they express their formula in terms of the number of ounces or the number of pounds necessary to make that size batch. And lots of times we'll see the old-timers, the people who are very rooted in the old-time tradition of fireworking, express a formula in a way that does not add up to 1 or 100. It'll be sort of an odd-looking total number that it adds up to, but there is some historical precedence for why that formula is expressed that way. But since I typically don't make large batches that will fill an old-time cut star loaf box full, I perhaps want to make a test batch of a star composition that totals 8 ounces, or I want to make 32 ounces of a composition that I know will make a 3 or 4 inch comet. I need to convert the formula that I find, such as 15.32, into factors that add up to 1, so that I can then determine how much of each chemical to weigh out. To convert a formula that does not add up to 1 or 100 to the factors that are useful for me, I add the parts of the formula, 15.32. I add all the parts of the formula to get the total parts that are there. 15 plus 3 plus 2 is 20. So that's the total number of parts that that formula refers to. If I then divide each of those quantities, 15, 3, and 2, divided by 20, I will get the factor for each of those individual chemicals. 15 divided by 20 is 0.75. That factor is then the factor I will multiply by the total batch size I want to make in order to determine the quantity of potassium nitrate to weigh out. 3 divided by 20 is 0.15. 2 divided by 20 is 0.10. So that's the way to convert a formula that is not expressed in percentages, or especially not expressed in factors that add up to 1. That's how to convert that formula, 15.32 for example, to factors that do add up to 1. 15 divided by 20 is at 0.75. 3 divided by 20, the total number of parts, is 0.15. 2 divided by 20 is 0.10. I verified that that adds up to 1, and indeed it does. 75 100ths and 15 100ths and 10 100ths add up to 1. And there then is my formula expressed in the factors that I find useful for working with a formula when I'm trying to determine how much of a chemical, each chemical to weigh for a certain batch size of a composition. So that is just a little bit of the math, some of the simple math that comes into play when we're working with a formula, especially a formula that's not loaded into some automatic database that we can use to determine the amount of each chemical to weigh, and especially when working with a formula that is expressed in factors that don't add up to 1. Now, if a formula is expressed in terms of factors that do add up to 100, I can then remember that 75 is actually 75 out of 100, which is 75 100ths. So if I move the decimal point 2 places to the left, I get 0.75. 15 out of 100 is 15 100ths. Move the decimal point 2 points to the left, and I get 15 100ths. If I take the factors like 10 in the 75, 15, 10, divide it by 100, and I get 10 100ths, I'm moving the decimal point 2 places to the left. That enables me to quickly convert a formula that does add up to 100, which is the way we'll often see a formula, convert that to factors that add up to 1, like 0.75, 0.15, and 0.10. So that's a little bit of the way I work with a formula in my mind mathematically in order to conveniently determine individual amounts of chemicals to weigh out for a formula, or how to express a formula in a way that is easy to use. I like to express all the formulas that I share in terms of factors that add up to 1. Once again, thank you for listening to all that, and you can completely ignore it now, because I will only, in Fireworking 101 at least, I will only refer to formulas that are in the database where you can plug in the quantity of composition you want, and it will automatically calculate the individual weights of the chemicals that you then weigh out for that formula.